Hello everyone, so welcome to my illustration assessment presentation for MH4 and today I'm going to identify, describe, connect the key features of polynomial functions. Specifically, so we will be exploring the bridges between their numeric, algebraic, and graphical representation. Okay, let's go to the next slide. So to build a polynomial graph from its algebraic equation, we must first understand its fundamental geometric constraints and terms like end behaviors and intercept connections and multiplicity. So let's see. So determining end behavior. So end behavior is determined by two main algebraic components. And the first one is the degree of the polynomial and the sign of its leading coefficient. So first one, the leading coefficient. So if the leading coefficient is positive, so the right side of a graph always rises towards the positive infinity. And conversely, so if the leading coefficient is negative, like as we see in the image, so the right arm always falls down towards the negative infinity. So okay, when we look at the degree, so the two ends point in the same direction, so even if both is up or down, so it doesn't matter. So it must be the same. So if it's the same, so it is even degree, and if it's not the same, so it's odd. So it's a bit clear here. Okay, so let's go to the next slide and the multiplicity and graph shapes. So an order of 1, so it means a function behaves linearly. The function is linear and it goes straight through the axis. And so an order of 2, that's a quadratic function, so it creates a turning point that bounces off the axis and it leaves the tangent point. So the third one, an order of 3, so it behaves cubically, so it's a cubic function and it's flattened out as it crosses through the x-axis and it creates a point of inflection. So in this case, and crucially, this is very important, so the sum of the multiplicity is equal to the degree of the polynomial. And so solving algebraic description, so it is from word problem to price equation. So okay, to write our equation, we have to use the general factor form equation. So, and as it is given, and to solve the problem systematically, so we have to follow 3 main steps. So the first thing is, so we have to identify the zeros, and the second, so we have to set up equation, and we put some unknown number, like unknown factor, like A, B, C, D, as we want. We can put anything. And step 3, so we use a given coordinate point on the curve to algebraically isolate and solve for the unknown factor, like A or B or C, and the unknown factor we have to find. So let's work it out in a real question. So I choose the question number 3, C. So it is given zeros at -1 and 3. So for -1 this is all 3, and for 3 this is all 2. So it pushes through the coordinate -2, 50. So here's my calculation. I just, and so it's point. So it pushes through the point -2, 50. So after all the calculations, we got the -2 for the unknown factor a is equal to -2. So the final equation, f of a is equal to -2 into x plus 1 the whole cube and x minus 3 the whole square. So we got it. So this is from solving from our description. And okay, here the graph. So is solving from the graph. So we can use this exact same algebraic technique when we are given a visual graph instead of text. So text is not given, only graph. So we can use the same technique. Okay, so the final part. So to find the symmetry, it is even or odd function. So to be even function, so the f of minus x must equal to the f of x. And for to be an odd function, so rotational symmetry. So f of minus x must equal to minus f of x. So when we work it out to our problem, so it does not fit with both. So it is neither even nor odd function. So this is the final slide, and this is all my presentation I prepared. So thank you for listening to my presentation and giving your time, and I really appreciate it. Thank you very much.